When I draw a circle and a line from a point to a point, this line is called chord. Now a chord divides a circle into two segments. This is segment and this is segment as well. So all angles in same segment are equal in size. Now if I draw angles in upper segment, all those angles will be equal. For example, if I draw an angle here and another one here and the third angle here, all those angles that are subtended by that chord, then all those angles are equal. Meaning that if the purple angle is 68, then the green one is 68 and the blue one is 68. Sometimes chord may be silent like this, it might not be visible, but all those angles will still be the same. So if I draw a chord BA somewhere else here, then the angle which is at P and at Q will still be the same. Even if the chord may be invisible like this, but those angles will still remain be the same. So if I draw a chord AB here, then all those angles subtended by AB will be the same. If one is 40, then all others are 40 degrees. Now I'm drawing a line which will pass through the center, and this line is called diameter. Diameter divides the circle into semicircle. Then if I develop an angle here and another one here, then the other here, all those angles are in a semicircle. Now all angles facing diameter are 90 degrees, or angles in a semicircle are 90 degrees. Whenever you see any angle subtended by diameter, it is 90 degrees. Now I'm drawing a chord here, and then an angle upside there. And then now I'm going to draw another angle at the center subtended by the same chord I've drawn. So in this case, the angle at the circumference is 50 and the angle at the center is 100. This means that the angle at the center is twice angle at the circumference when they are subtended by the same chord. If angle at the center is 80, then at the circumference will be 40. So goes on. Chord bisector. If I draw a chord and bisect it with a perpendicular line, that line passes through the center. So we say a perpendicular bisector of the chord passes through the center. Equal chords. Chords of equal distance from the center are also equal. For example, there is a chord CD there and AB. The length of AB has to be the same as CD. So any chord of same distance from the center, they are also equal. If I produce a point P, then angle which is facing at AB, and another point Q, and an angle which is facing at CD, those angle Q and P has to be equal because they're subtended by the chord of same figure, which its all angles are touching the circumference. If you have a four-sided figure which some of its angles are not touching the circumference like this one, it's not a cyclic quadrilateral. So in a cyclic quadrilateral, all angles of the four-sided figure has to touch the circumference. So in cyclic quadrilateral, opposite angles add up to 180 degrees. This means if this angle is 86, then the sum of the angles has to be 180 degrees. Therefore, this other angle should be 94. If angle E is 110 degrees, then angle D has to be 70 degrees. If I extend line CD of this cyclic quadrilateral and project an exterior angle, now the exterior angle which I've produced here, it's equal to opposite interior. Opposite interior, it's angle BAD, and exterior angle, it's angle ECB. Those angles are always equal in cyclic quadrilateral.